Good morning, good afternoon, and good evening to everyone joining us today. So today's webinar is about secure development on Salesforce platform. It's a part 3 webinar. I'm joined here with Swapnil Shinde and me, myself, Nitin Arya. I'm a product security analyst at Salesforce. I work on Apex security reviews. I mostly work on these reviews, then I talk back to partners and help them fix those issues. I've been helping understanding the security bugs within Salesforce, and I help the teams here remediate those security issues. I help them out during the security review process. I build some internal tools that we use within our security reviews in the Salesforce. I'm joined here with Swapnil Shinde.
Hello everyone, this is Swapnil Shinde and I work as a product security engineer here at Salesforce. Nowadays, I'm working with a team which is focusing on building security into our community cloud product. I also spend some time on reviewing the apps that are submitted on Apex, and I get a chance to talk with partners sometimes in order to resolve their issues. That's about me. Giving it back to Nitin.
Thank you, Swapnil. A quick legal statement, guys. Don't make any financial decisions based on this presentation itself. All the features that we're going to talk about today are already available on the Salesforce platform. So, agenda for today's talk. I'm going to be covering the external application integration within the Salesforce. And the second part is going to be done with by Swapnil, where he'll be talking about secret storage in Salesforce platform. Um, More of the partners, whenever you want to integrate some external application or service within Salesforce, you can use the Salesforce platform in a more secure way. So we're going to talk about what are the ways you can integrate your external applications securely within Salesforce. Now, once you have these external applications talking to the Salesforce platform, you also want to map the user identities. One of the more complicated, or let's say basic approach would be that you create new user profiles and do the whole authentication and access control measure on your external service. But we are going to talk about how you can leverage and use the Salesforce platform and map user identities from Salesforce in order to authenticate to those external apps or services. And you want to grant access to Salesforce data without breaking security model. Salesforce security model is that any person should be given the least amount of access that he needs in order to perform his or her duties. So you only want to give them access to the resources or data that they need in order to fulfill their duties, not anything more than that. So building Salesforce integrations. So as we already talked, it extends the Salesforce functionality with external app integration. So you're integrating external apps within Salesforce. You can use the Apex code and create custom APIs for your use case. You can build data flows and you can interact with your external application on Salesforce. As we already talked, you can map the identities within Salesforce for authentication or authorization when you're pulling or pushing data into those external services. So integration method. One of the most commonly used methods used by developers is Apex callouts. Apex callouts provide a way for you to make calls to your external services. Apex callouts can use the REST APIs for this purpose. They can be used to push and pull data within the Salesforce platform. But one of the things that we mostly see in partners code is that these actions or Apex callouts are not mostly initiated by a user action, which sometimes creates a security problem in terms of if the data is actually requested by the user, then those actions must be initiated by user action rather than just automatically retrieving user data from the external services or pushing data from the Salesforce platform itself. So there are a couple of authentication or authorization method that we use within that integration. You can use the SOAP API, which will lead you to a user password-based login, or you can use the OAuth authentication flow within your applications. Easiest way is by using the OAuth. You receive an access token. Access token is a credential that Salesforce issues to you based on the scope user agreed to give access to. So once the authorized user is now okay with the access that he wants to have for that particular API, for example, the user has authorized you to that you can access his chatter API, then you can make requests. You can pull data from Salesforce or post it back. You can also write down your custom Apex endpoints that I'm going to talk about in the next slide probably. So as we already talked about, there are two-way kind of APIs supported by Salesforce, SOAP, and REST. External services can authenticate with Salesforce via OAuth, and as we said, we can receive these access tokens. These access tokens are kind of like temporary passwords, so you use these access tokens to access the data within Salesforce. Now, as I was saying, they're kind of like temporary tokens. They provide access to the users. You want to make sure that they're treated with the same level of security as any other password or encryption key. The second part of this presentation, which is about secret storage, will cover all the key points on what guidelines you should be following in order to secure those credentials or these access tokens securely. You can utilize public facing APIs to share data with Salesforce instances. One other point that I want to talk about is the outbound messaging, and developers can expose custom Apex REST endpoints. What that means is you can use the already included REST API within Salesforce, but you can also create new custom Apex REST endpoints within Salesforce. We mostly suggest that you stick to the API provided by the Salesforce, but if you still need to write custom API or expose REST endpoints, you can do that too. And you can use Apex callouts to push and pull data within Salesforce. So outbound messaging is one of the feature which a lot of developers are not familiar with. It's so suppose you have some fields and you want to, for example, raise a message or alert your services that something has changed in Salesforce. For example, if a user has added this new payment, for example, or user has submitted a new message. So what outbound messaging does is enables you to initiate a message which kind of alerts your external service that something has changed in this XYZ field, for example. But you're not actually sending the field itself. So it's not like you're actually pushing the data, but it's just like a messaging system. Just sending one way message to kind of send like an alert so you can maybe initiate some kind of trigger or action on your end service based on that message that you received. So connected apps. So connected apps runs on the Salesforce app canvas. That's one of the way we integrate external applications within the Salesforce platform in a more secure way. Uh, we done one of the from a security point advantage of using a connected application is that you do not grant access to Salesforce DOM. So what that means is, to be more precise and clear, is if there's any vulnerability within your connected app, then it kind of runs into an iframe sandbox environment. So the whole Salesforce data or DOM is not exposed to any kind of security vulnerability. You can provide authentication via OAuth or SAML using the Salesforce credential. So it's an easy way to integrate an external application within the Salesforce app canvas without any kind of security risk, to say. The OAuth scope, the one that you're going to use to authorize your application, determines the scope that that external application has access to. Um, I'm going to talk a little bit about the scope when you're authorizing an application and the users within those APIs, because that's really important because you want to make sure that data you're granting access to that user depends per user. So what that user needs, minimum requirement. So you're kind of not breaking the Salesforce security model. So which is also the principle of least privilege. So just as I was talking about that user, that you want to make sure that you stay within the scope of the user, which is requesting the data access. So there are two kind of ways we see developers integrating the users for authorization within those connected apps, or for example for APIs, for example. So you can create an integration user. What integration user means is you can create a user, for example, API user, and then you use that user to make all the calls for your APIs or within your application. But there's a big security problem with integration user, which is that you are not providing or taking access for data based on per user. Instead, you created one user, which is like API user, who's making calls for all the other users. Some users might not need that much data access as compared to, for example, user A. Maybe he just needs to access to 2 or 3 fields, and maybe user B needs access to only one field. Now, an integration user, he or she can pull data for because the user permissions are set for that integration user, not per user level. So we say that you should always include the end user permissions, which is like you're authorizing application based on per user, which is also the OAuth flow of Salesforce that I'm going to show you as a demo, that how you can authorize per user basis on Salesforce platform. And once you map those users that are created within Salesforce, his or her permission sets and access levels are automatically implemented within the Salesforce platform. So end user, as I said, it lets user to select actively what exactly the access he or she should have to. The external app needs to make sure all end users OAuth credentials are stored securely on external system. So yes, so once you receive the OAuth tokens or that access token, you want to make sure those access tokens that are going to be generated for the user are secured securely within your applications. So I'm going to do a quick demo here or how you can create a new connected app. Um, I'm also going to, so you can go to your setup and you can create a new application there. Then I'm going to talk a little bit about this second application, which is the link will be in the presentation, or I'll also leave the link in the chat. This is a sample app that our developers can use to test their external applications. It kind of, on the right side, it kind of shows the whole OAuth flow for the application. So let's get into the demo now. So so here I can go down to setup, build apps, create apps. I go to my apps. I go to the bottom of it, and here it says connected app. So I can go ahead and create a new connected app here. So I can click on the new button. I can name my app anything here. So I'm renaming my application here. I want to make sure I enable the OAuth settings. So I tick this box, which enables the OAuth settings. And then here I have the selected OAuth scope. So what that does, it's asking us what's the scope or the user access level that a user needs. So you can go ahead and click access and manage your data. So I go ahead and add this OAuth scope. We need a callback URL. So the way the OAuth works, it's going to make a request to Salesforce. Now Salesforce needs to know a URL where he can receive that token. So you provide the callback URL here, and then you can save your demo applications here. I've already done that, so I'm not going to do it here right now. So here I have one more application that I just created earlier. Once it's done, you'll see a screen like this. You have a consumer key and you have a consumer secret. Both of these fields should be treated as sensitive fields. I go back to the test application. This application, anyone can access this application. So all the developers can go ahead and use this application to test their OAuth, for example. So here I have the fields, the host fields, which is like the main Salesforce host. I have a consumer key. I have a redirection URI. I have authorization code. Let me just go back to the first. Okay, so that's the main page. So I'm going to go back to my demo application. I'm going to copy the consumer key from here, and I'll provide the consumer key in this field here. And I'm going to request the authorization code. So it's asking me, should I give access to? I'm going to click allow. Now it's going to ask me for a consumer secret. So I can pick my secret from here. And I fill up my consumer secret right here. And this generates the access token URL that will be used in order for us to receive that access token. So now this is done. So this is my access token. So I can always use this access token in my request to access any information as per the allowed security settings that we set up for this user itself. So what are the advantages of using connected apps? There's no need to add custom authentication logic. You don't have to map and create separate user access controls within your external systems. You only use what we created in Salesforce. You are still um, um, following the principle of least privilege access on your external application. It's super easy to revoke access for misbehaving apps, as you can just go back there and delete the application, and that's it. It provides all the functionality of OAuth protocols, and you can also can provide access without sharing any Salesforce username and password with the external application. This one is a really important one. So whenever you are doing this OAuth flow, you're not sending your creds for Salesforce over to the external application. Instead, creds or credentials are going back to the Salesforce, which provides you with a temporary access token, so you're not sending over your Salesforce user and password to anywhere else. So credential handling, the external app credentials, consumer key, and secret, which we saw in the application, should be stored securely. Swapnil is going to talk more about it in his part of the presentation. API tokens for external application should be stored via custom protected settings. I'm going to be talking a little bit about the transport security, which is the TLS for all the communications that your apps are going to go through. So what that means is that when your these external applications and Salesforce are communicating, what are they encrypted or not? Can someone do a man-in-the-middle attack on your data? So if you're using typical HTTP, there's no security. Anyone can eavesdrop on the data, and anyone of the network can divert this traffic. So how can we secure this? So your server is talking to your Salesforce instance is talking to your external service or software, then how are those two servers going to communicate securely? And that's the whole objective that we are trying to achieve here by implementing TLS, or in Salesforce we call it mutual TLS. It's like for server to server communication security. So anything that is sent over HTTP has no security. I think a lot of people already know that. What HTTPS use, I'm not going to go too deep down into how this works. It uses PKI. It prevents any kind of tampering, eavesdropping, or man-in-the-middle attacks if all of your servers are communicating over TLS. So mutual TLS. So Salesforce supports mutual TLS for communications between Salesforce and external servers. This allows your servers to have a two-way verification where client and servers, they can confirm each other identities. It's good for server-to-server authentication where client is not prompted for a user to log in manually. So your servers don't have to log in. For example, suppose I'm accessing some website, so I log into it, my communication is encrypted. But for servers, they don't have to log in every time. So you generate certificates and you store a certificate within Salesforce, and you can also take out the Salesforce certificate and store it in your external application. Then both of them can can communicate securely, and they both trust. So both parties are basically trusted. It's a typical flow. So both servers kind of send like hello message, and they both provide their certificates. Then they agree on a key exchange, and then the whole handshake is finished, and they can start communicating information back and forth. So client certificates are uploaded in Salesforce database where they're used for verification. So you need to provide your client's certificate to Salesforce, and Salesforce can store it, and then they use it for verification. And as I said, you can also do it the other way where you download it from Salesforce and use it within your external application. So that's you can generate a certificate signing request. So this is the form. This is all the certificate details that you need in order to get a certificate from an authority like VeriSign. So you fill out these fields, you generate your CSR, and then you can submit it to VeriSign and receive your certificate. That's the certificate that we need in our Salesforce instance, so Salesforce can verify your server's identity. So you take that certificate, you upload the certificates into security controls, certificate and key management. So which is right here. If you just search for certificate and key management, and that's the screen that you're going to see. So you can enable the SSL TLS authentication permissions for the API client user, and this will force the port for this TLS communication to be on 8443 port for this user. Um, so once that certificate is stored within the certificate and key management, they can configure the API client on this port and they present that client certificate and the verification happens and two parties can successfully communicate over an encrypted channel. As you can see, I took a screenshot of it too. You can create self-signed certificates up top, a certificate for Salesforce. You can import Salesforce certificate from this window and you can upload your external application services and set up the mutual TLS for communication. So why use mutual TLS? Because it provides a good way to authenticate both parties when you're building external integrations within Salesforce. You don't have to rely on any IP-based restrictions because those parties are only going to communicate if those certificates are valid, and provides an easy way for authentication and confidentiality. Now, please leave your questions in comments. Second part, Swapnil is going to talk about secret protection.
All right, hello again, everyone. Let's jump into the second part, which is secret protection. How you can store your secrets securely on Salesforce platform. That's what we are going to cover in this second part. So we'll be covering the developer-oriented topics on secret storage on our platform. Specific topics that we are going to cover are secrets in name credentials, secrets in custom settings, and guidelines for proper secret usage. Now, this particular part is geared towards all Salesforce developers primarily. However, if you are a Salesforce administrator or a prospective partner, and if you're interested in this topic, then you will get value out of it as well. What is a secret? A secret is a piece of data that requires higher than normal protection. So for the purpose of this presentation, a secret could be either a password or an encryption key that is used by the developers to talk with the external systems. So when you're talking with an external system, you need to secure your communication with a password or an encryption key, for example, an OAuth key or something. How do you store it securely on the Salesforce platform? That's what we are going to cover. It is very important from the security perspective. Who do we secure the secrets from? Obviously, we secure the secrets from the attackers. Sometimes there is a need to secure the secrets from the regular users and partners of the org as well. Because suppose you are talking with a sensitive service, which is an outside third-party service, and if you want to secure the credentials or the keys that you are using from the regular users and partners, you should be able to do that. And I'm going to show you how you can do that. There are needs where you want to secure the secrets from administrators, and this is the biggest challenge because admins have access to everything, right? So we have ways to secure the secrets from even administrators, and we are going to see that. Now, why do we need to secure these secrets? Now, these secrets are securing the data or they are securing the user identities on the external systems. So in order to prevent the theft of data or impersonation or problems like privilege escalations, we need to secure the secrets securely on Salesforce platform. And I'm going to show you the three ways by which you can secure the secrets along with demos as well. The first way to do it is storing the secret in named credentials. So named credentials are the features in Salesforce platform that you can easily configure with point and click. And it is available under the security setup menu. And you don't even need to write any code in order to store a secret in named credential. How do you use name credentials? As I mentioned, it is available under the setup menu. You create a new name credential and then you add the URL and secret to that name credential. The secret is either the password or OAuth token that you are going to use to make a call out to that URL. And the URL is also written in the name credential. And you're going to invoke that name credential into an HTTP request. So here is a small code snippet. What we are doing here is we are going to create a new HTTP request and we are going to set endpoint and we are going to call out with the name of that name credential. Here, the name of the name credential is name credential. And that particular name credential will have your secret as well as the URL. So once you form your HTTP request and once you make a request, the callout will be made to that particular URL with the secret that you have mentioned in the name credential. What are the pros of this method? It is very easy to create, and I'm going to show you in the demo as well. It is very easy to invoke. The secret is not visible to any of the user of the org in the UI, as well as it is not leaked in the code anywhere. Also, the secret is not leaked into the debug logs. So as a secure developer, we need to make sure that our secrets are not even leaked into the debug logs. It is very important. The cons of this method are it only works for HTTP request basic authentication and certain authentication schemes like OAuth 2, 2.0. So if you are using any authentication scheme which is outside these two schemes, then unfortunately you won't be able to use name credentials. However, there is a next method that you can use in those cases. And there is a rare possibility or there is a rare scenario in which the administrator of the org could potentially leak this secret. That is the only problem of this whole scheme. If the administrator of the org accesses the name credential and if he changes the URL, then the secret will be sent to a new URL. So he cannot access it through the UI. He cannot see directly in the org, but he can do it in this convoluted way. However, it is fairly secure scheme. It only not effective against the administrators, but against all other users who don't have access to name credentials. This is a fairly secure scheme. All right, so let me show you the demo of name credentials. So this is my demo org. This is a Trust Academy org. If you know what that is a training program for our developers. And this is a demo for named credentials. What I'm doing here is, if you look here, I'm making two calls and I'm two call outs basically to an external service, and I'm getting the same results. Now the first call is made in an insecure way, and the second call is made in a secure way. I'm going to show you the code how those calls are made. Here I want you to just focus on the results that are coming back, and those are identical results. So if I refresh the page, the calls will be made again, that you can see from these request IDs. These are changed. So the calls are made same. Uh, and I'm now going to show you how these calls are made in an insecure as well as secure fashion. Now, certain people have questions that how these secrets are generated. These secrets you obtain from an external service. Okay, these are the passwords or encryption keys or OAuth tokens that you receive from external services. We are focusing on how you can share them securely on the platform. So let's check out the code for how these calls are made. Now this part of the code is the first call out. What we are doing here is we are making a new HTTP request and we are storing the username and password uh, in the code, and these username and passwords are exposed in the code, which is a bad security practice. You should never do this. Then the call is made and we are logging the call in the debug log as well, which is a bad practice. Do not code in this fashion. What you can do is you can form your request as I showed in the slide, and then you can see you can use call out with the name credential, which will make a call out to the URL which is mentioned in the name credential, as well as with the secret that has been specified in the name credential. How to define these name credentials? It is very easy. As I mentioned, you go to setup menu in your org and you search for name credential here. So I'm going to edit the already existing name credential. So the name is name credential, the URL is this where we are making the calls, and the username and passwords are here. As we have mentioned, if you make the calls in this fashion, the username and passwords are not going to be leaked in the code as well as in debug logs. So let me show you how these are not leaked into the debug logs as well. So if you go to your debug logs, and I'm going to delete all the logs which are already there. And I'm going to go back and make a request again by refreshing this page. So these are the two new requests that are made. Let's see if we have those in the debug logs. We have it. And then I'm going to search for my logging of the authorization headers. So this is the first request, and it says that the header is logged here, and this is my username and password in base64 encoded format. So it is leaked in the log when you are making a call by hard coding your username and passwords in the code. But however, this second call which is made, it is returning null for the HTTP request header. So if you use name credential, your username and password values won't be leaked in the logs, and that's why this method is secure. All right, this is the first method. Let's move on to the second method to store secrets. Storing secrets in manage protected custom settings. So what are custom settings? Custom settings are stripped down as objects exposed to the application cache, which developers can use. Um, if you write protected in front of the custom settings, then these custom settings are only available in the manage package where those are written. So only in the namespace of the manage package, these custom settings will be available. Um, what does this mean? So if you are saving your custom setting in a managed package which is outside your org, and if you install that managed package inside your org, then those custom settings will be only available from that managed package. That's why you need to define these custom settings as managed protected custom settings. If you define them as managed public or local protected, they do not give you any security benefits. And I'm going to show you the demo for all these concepts. But just remember, this is a mouthful, but just remember that if you want to store secrets in custom settings in a secure way, those should be managed protected custom settings. How do you create managed protected custom settings? So creating a managed package is outside the scope of this presentation, but just remember to create a managed package in some other org than your own org, okay? So that the namespace of that org will be different, and the things that are stored in that org are not, and the custom settings that are stored in that org are not visible to your own org. So you need to create a managed package in a different org, maybe a developer's org, and then create a protected custom setting inside the package of that org, as shown here, and then create a Visualforce page inside the package to create and update the secret, and then access the secret inside the managed package only, and then to make a call to that particular custom setting from your org, and I'm going to show you the demo for that as well. So let me clarify that with a very simple diagram here. If you see, the outer rectangle is our org in which you are working, in which you are writing the code. That is an outer rectangle. And if you write a protected custom setting in an outer org, that will be available to all the users of that particular org, okay, which is not a good design. So what you need to do is you need to install a managed package here. I'm showing it here, which is an inner rectangle. And in that managed package, you need to store the protected custom settings as shown here. Now, no user of your org will have access to that protected custom setting, okay? And no Apex call made from your org will have access to it. Only the Apex code inside that managed package will have access to your protected custom setting. What you can do is you can write a global Apex method which will be available to an Apex code running inside your own org, and that will make a call to handle these protected custom settings. So what you need to understand here is if you create this encapsulation for your protected custom setting, then it will be secured from all the users of your own org. What are the pros and cons of this particular method? Now, this is the best standard method that we recommend in order to store in order to store the secrets. The pros of this method are the secrets are only available to Apex code within managed package namespace. The users of your org where you're developing the code won't have access to those secrets, which is what we want. Now, if you want to scale this particular model, what you can do is the most secretive data, like encryption keys, are stored on inside managed protected custom settings, and all other data could be encrypted inside your org using that encrypted key, and you can use Apex calls to encrypt the data in your org. The cons of this method are you need a managed package in order to use this particular method, and you need to follow certain security guidelines that I'm going to cover in the presentation next if you are using this managed protected custom setting method. So this is a same diagram with more details. As we have seen, we installed a managed package, this managed package inside your org, and you are using the protected custom settings here. In order to set these settings or these secrets, what you do is you write an Apex controller inside the managed package, and you use the transient string for your variables to store the secrets. I'm going to cover this next. Okay, just remember the transient word right now, and you're going to create a VF component for storing the secret in this protected custom setting, and you are going to create a Visual Force page in your org which will access this Visual Force component in order to store your secrets inside this protected custom settings in managed package. Now, when you are making a call out to an external service, you'll use the Apex web service, which is inside your managed package, and there will be a global invoker which will be used by a schedule job or trigger or dev console, things like that in your org. This global invoker will be invoked from there, which will access this Apex web service, which will only have to these protected custom settings. All right, let me show you the demo for this. Now, this is a very simple page where I'm storing the secrets using two methods. This is local protected custom setting, and this is managed protected custom setting in a managed package. Okay, so in the local protected custom setting, I'm going to show save the secret as LP secret, and in the managed protected custom setting, I'm going to show save the secret. Let's treat this as a secret, and the name of the secret is MP secret. Now, what we said is if you store it in a local protected custom setting, it is not secure. It is available to all the users of that particular org. So I'm going to show you the demo for that. Uh, I assume that you guys know what the workbench is. The workbench comes as a plugin in Chrome, and which gives you an API access to your org. Okay, so so you just need to press this plugin, and then the workbench will open, which will give you an API access to your org with the current logged in user. You're going to select the SOQL query, and then you're going to look for the objects. Now, when we are storing the objects in local protected custom setting, the name of the object in the backend code is secret custom setting underscore underscore C. So I'm going to select here that object or that custom setting, secret custom setting. Let me find it out. Secret custom setting underscore underscore C. So it is shared as a local protected custom setting in the same org, and I can make a query, name and value. So it is going to select name and value from that secret custom setting, which is a local setting. And if I query through API, I can see the value of that particular secret. So this is what we need to see here is if you store a local custom setting, then it is available to all the users through API call. So you shouldn't do this. What you need to do is store them in managed protected custom setting. So here I have stored the managed protected custom setting variable inside a secure storage namespace with the name secret underscore underscore C. So let's see if we can query that using a API client. So we are looking for secure storage. What's the name again? Secure storage namespace, and for secret underscore underscore C. So let's see for secure storage namespace. But if you see here, you do not see an object secret underscore underscore C under secure storage namespace. There is a different object called public underscore underscore C that we haven't created. That is a public. So what you need to understand from this demo is if you store your secrets in managed protected custom settings, then those secrets are not available through through even an API call to any of the user of your org. All right, so the last part I want to cover is when you're going to use manage protected custom settings, which is the best thing you can do in order to in order to store your secrets, you need to be aware of these three things. Properly encapsulate your secret in a managed package, properly handle secret dependencies, and avoid secret reflection. I'm going to cover this one by one quickly. Properly encapsulating your secret. What does this mean is your secret should be in a managed package. It should be only available to a Visual Force page or component inside that managed package in order to create that secret or modify that secret. The code which deals with the secret should be inside the managed package, and only the invocation of that secret should be done with a global method which is exposed to your own org. So this diagram again, for to understand this invocation, your secrets are stored inside here in the managed package, and in order to set secrets you are writing apex controller code and vf component, which are inside the managed package, which are accessed by a Visual Force page in your org. And when you are making a Apex callouts, use an Apex function or Apex code inside that managed package. Only expose this functionality through a global invoker to different things in your org. So this is an encapsulation. You need to understand this and prevent any other access to these protected custom settings except a global invoker or a VF component. Properly handling secret dependencies. If there are dependencies on the secret, like there is a secret and there is a corresponding URL, then when the user changes the URL, then the secret should also be changed. The user shouldn't be only changing the URL and the secret is still there. Then the secret will be sent to a new URL. I'm going to show you in the demo what I mean by that. But when there are secret dependencies like a password and URL, both should be changed simultaneously, and the user shouldn't be able to change one of those two. And the last thing is to avoid secret reflection. Beware of hidden inputs when you're writing codes. You shouldn't use hidden inputs as the only way to protect your secrets from users, because users can still see those secrets in the code of the page if they even if they are not seeing it in the UI. And use the transient word when you are dealing with the secret in an Apex code that prevents the secret to be leaked in the view state. All right, so I'm going to show you the demo for handling the secrets. So let's consider this is a very simple form that is available to your users in your org. You need to store some secret, you need to store an endpoint, and then you're filling out these details, and then you are making a payment, and the user can make a payment to this mentioned endpoint with these details. Now here, this secret is stored, but it is also reflected back to this form. And though the user cannot see it right now because this is a hidden input field, if the user do view page source of this particular page, he can see the secret here. Here it is. This is a basic. This is an OAuth token actually, and this is how the secret is exposed. So don't just rely on the hidden inputs of the form. Use the words transient in the backend so that secret is not reflected back to the UI, and make sure that the secret is not available in the code of the page. And also, this is the endpoint where the secret is being sent. If I can change this, and if I store this endpoint, then this particular secret will be sent to this endpoint when I hit process payment. This is a bad design. You shouldn't be doing this. Let me show you the good way to design this. So over here, whenever I store a secret, it is stored here as shown along with the endpoint. So if I try to change just the endpoint in order to send this secret to this endpoint, and if I click on store values, it is going to tell me that secret and endpoint must be both set simultaneously. So there is no way I can send this particular secret to the URL I want. And also, if you see, the secret is shown in stars here, but if you go to the view page source, the secret is not protected by just hidden inputs, so it shouldn't be available in the in the back in the code as well. So the secret here is written in stars as well. It is not protected by just hidden inputs, and the word transient is used in the Apex call in the manage package so that the secret is not sent to the view state, so that it will be leaked to the UI or to the view of the user. All right. The last thing I'm going to cover, not in detail right now because the lack of time, and this is a very new method. So you can also store secrets in manage protected custom metadata types if you don't want to use manage protected custom settings for some reason. This is a very similar concept to manage protected custom settings. I just want to touch it because it's a latest addition to our platform. I don't have the demos for you right now and expect more material to come from us in future on this, but just keep in your mind that there is one more way to securely store your secrets, which is very similar to manage protected custom settings. You are storing your secrets in manage protected custom metadata types. Uh, the only advantage it has over manage protected custom settings that you can update your secrets using metadata APIs in the manage package where you created that metadata type. So let's recap the second part of the presentation. You can store your secrets using name credentials, which is very easy. You don't even need any code to do this. The secret is not reflected in the UI or debug logs when you store the secrets using this method. The only problem with this method is that the secret could be leaked by the administrator of the org in certain cases, which is a very rare possibility. This is fairly secure scheme, and this only works with passwords and OAuth tokens. If you want to follow our secret storage best practice, then you need to store your secret in manage protected custom setting. The advantage of this option is it's the most secure option. It protects against user with elevated permissions. Even if they have the most elevated permissions, even if they have administrator privileges, or if they have permissions of modify all data in the org, they won't be able to access this secret because the secret is stored in a managed package outside your org in a different namespace. The only drawback of this scheme is that you need to have a managed package in some other org, and you need to require careful attention to the code with these three best practices that we have seen, that properly encapsulate your secret inside a managed package, properly handle the secret dependencies. For example, if you are updating the URL where the secret is sent, the secret should be updated as well. They shouldn't be able to just update the URL, those kinds of dependencies. And you should not reflect the secret back in the UI. Just do not rely on the hidden inputs and use the transient word in the Apex code where you are handling the secret. This code will be in the managed package. All right, these are some additional resources. We have covered a lot of things today, but you will find the material to study them more. Some of the orgs that we have shown are available here. The last resource, the Security Essentials course in the Trust Academy. You can check out those things and do some hands-on training over there as well. I'm going to keep this screen when you guys are sending the questions. There are new trails that we have designed from the security perspective. You can earn the two new badges. There's a very cool trails that we have just introduced in last Dreamforce. The badges are Injection Vulnerability Prevention Badge and the App Logic Vulnerability Prevention Badge. So I assume that you guys know what a trailhead is. This is our education portal where you can log in and work on different assignments and hands-on experiences. So check out Trailhead and these new trails for sure. With that, we are ready to take your questions as promised. And keep sending your questions in the chat box, and then we'll answer them one by one.
So first question, I'm going to start from the in a sequential order. Our local. First, I saw someone pointing out that Dewey is the code available on GitHub for these demo orgs. So I just want to point back a little bit to 3 slides back. As you can see, force.com security essentials code. You can go down there on trustacademy.salesforce.com, and all of the demos are there. So you register and do this course, and you'll be able to go through all the demos that we did in this webinar. I repeat again, it's trustacademy.salesforce.com if you want to go through these demos again. All right, so the first question is, are local custom settings equally secure? No?
Um, yeah, are local custom settings equally secure if I use protected instead of public? No. Uh, so if you use protected even in the local custom settings, that will be available to the users of that particular org. Okay, so protected just means that these particular secrets or these particular objects are available in the same namespace. So that is not a way to store your secrets. Uh, you need to you need to store your secrets in a managed package in a protected format. Do not store them as locally, even using the word protected.
Awesome. So we have another question, which is, in a managed package, we have a private custom settings where secrets are stored. If partner logs into customer org via LMA, can they see the data? What's the LMA he's referring to? What's the LMA? Okay. Can see the data in the custom settings while looking at the Apex debug logs that access the custom settings. I believe if the code does debug of the secret, then it will be shown. So don't do any debug statements on your secrets. But the customer org won't show the secrets stored in the customer custom protected settings. So if you are doing a debug on it directly, then yes, it will be shown.
Okay, the next question we have is, can the name credential accessible in Apex if I want to use it for endpoint? Yes, as I shown in the demo code, in the Apex code, those name credential are accessible. There is one particular line I showed how you can make a call out with the name of the Apex, with the name of the name credential. If you just mention that name of the name credential, the secret will be sent to that endpoint, to that HTTPS endpoint, um, whatever URL you have mentioned in the name credential.
Awesome. So I already took this one, which is a sample code available on GitHub. Yeah, go to trustacademy.salesforce.com. Then I have another question, which is, some services require API key and a username and password. So can I use that, and how can I parse them, and what's the best practice around it? So you can store user creds in custom protected settings and then call them out in Apex code. Then you can form that URL and perform those queries, and you can do it vice versa too. You parse that, although it's not the best way, but you can like parse your API URL within Salesforce code, and then you can just like store those grads in the custom protected settings. Don't put them in like some global variable and keep them there. So just like if you wanna just pull some username password, store them in, rather than storing them directly in some object. You store them custom protected settings, and then you can call them in your Apex code whenever you need them.
All right, the next question is managed protected custom settings. Um, Managed protected custom settings will only apply to partners. Um, right is the question. I don't think, but let me read the whole question. Not customers who do their own development. In relation to my question, what are the suggestions for customer or developers to store secure settings without namespace or package? So this is the thing we suggest, and we highly recommend that you use managed protected custom settings to store your passwords. It is not only applicable for partners. No, it is applicable to every developer and every customers. So what you can do is you can have a developer org or some other org which is outside your production org, and save your create your managed package there. So and then use that particular encryption key or secret by installing that managed package inside your org. So it is applicable to everybody who is developing on Salesforce org. If you don't want to use managed package, then you can also use name credentials. However, there are some limitations to name credentials, like you have to use it for HTTP basic authentication and OAuth.
Awesome. So what is the scenario you want to use, the integration user or end user login in integration? So one of the example of integration user will be, for example, you have an API whenever someone adds a new user or like a new account, you want your external application to send some data to your main server. or because then it's not user based, and we're taking for instance that everyone in your org has access to accounts, so you don't want to have any boil down permissions per user. So this is like something really general, so you have an action and response is like, hey, I'm adding this XYZ thing, and then I want, uh, irrespective of who does that, because everyone in my organization can do that. So I'm going to create an integration user because then I don't need, because everyone in my organization needs that resource, for example. But when it comes down to, for example, Salesforce kind of model where you have objects and you have fields which are like user dependent, then you want to make sure that you use end users, because then the whole permissions and profile sets are rendered useless if you're not using end user based integration.
All right, so we are almost at the end. I'm going to cover one more question. Is there a limitation on how much data that can be saved in managed protected custom settings? That's a good question. Yes, there is a limitation. You can store 10 MB of data in managed protected custom settings. However, you can scale this model very easily. As I mentioned, you can store only the secret, like an encryption key in managed protected custom settings, and all other data like credit card or SSNs and all those things. If you want to store encrypted, you can use Apex encryption methods in your org, and you can encrypt all that data inside your org, and then just save or store the encryption key inside managed protected custom setting inside a managed package. So that's how you can scale with this authentication scheme. All right, with that, that concludes today's webinar. Thank you everyone for joining us today. If we did not get to your specific question, please reach out to us in the forum, and we'll try to answer as many questions as we can, and we'll answer all the questions. So reach out to us in the forum. With that, we are concluding the webinar. Enjoy your day.
Thank you. Map the user identities. One of the more complicated, or let's say basic approach would be that you create new user profiles and do the whole authentication and access control measure on your external service. But we are going to talk about how you can leverage and use the Salesforce platform and map user identities from Salesforce in order to authenticate to those external apps or services. And you want to grant access to Salesforce data without breaking security model. Salesforce security model is that any person should be given the least amount of access that he needs in order to perform his or her duties. So you only want to give them access to the resources or data that they need in order to fulfill their duties, not anything more than that. So building Salesforce integrations. So as we already talked, it extends the Salesforce functionality with external app integration. So you're integrating external apps within Salesforce. You can use the Apex code and create custom APIs for your use case. You can build data flows and you can interact with your external application on Salesforce. As we already talked, you can map the identities within Salesforce for authentication or authorization when you're pulling or pushing data into those external services. So integration method. One of the most commonly used methods used by developers is Apex callouts. Apex callouts provide a way for you to make calls to your external services. Apex callouts can use the REST APIs for this purpose. They can be used to push and pull data within the Salesforce platform. But one of the things that we mostly see in partners code is that these actions or Apex callouts are not mostly initiated by a user action, which sometimes creates a security problem in terms of if the data is actually requested by the user, then those actions must be initiated by user action rather than just automated within Salesforce. We mostly suggest that you stick to the API provided by the Salesforce, but if you still need to write custom API or expose REST endpoints, you can do that too, and you can use Apex callouts to push and pull data within Salesforce. So outbound messaging is one of the feature which a lot of developers are not familiar with. It's so suppose you have some fields and you want to, for example, raise a message or alert your services that something has changed in Salesforce. For example, if the user has added this new payment, for example, or user has submitted a new message. So what outbound messaging does is enables you to initiate a message which kind of alerts your external service that something has changed in this XYZ field, for example. But you're not actually sending the field itself. So it's not like you're actually pushing the data, but it's just like a messaging system. Just sending one way message to kind of send like an alert so you can maybe initiate some kind of trigger or action on your end service based on that message that you received. So connected apps runs on the Salesforce app canvas. That's one of the way we integrate external applications within the Salesforce platform in a more secure way. Uh, we done one of the From a security point, advantage of using a connected application is that you do not grant access to Salesforce DOM. So what that means is, to be more precise and clear, is there's any vulnerability within your connected app, then it kind of runs into an iframe sandbox environment. So the whole Salesforce data or DOM is not exposed to any kind of security vulnerability. You can provide authentication via OAuth or SAML using the Salesforce credential. So it's an easy way to integrate an external application within the Salesforce app canvas without any kind of security risk, to say. The OAuth scope, the one that you're going to use to authorize your application, determines the scope that that external application has access to. Um, I'm going to talk a little bit about the scope when you're authorizing an application and the users within those APIs, because that's really important, because you want to make sure that data you're granting access to that user depends per user. So what that user needs, minimum requirement. So you're kind of not breaking the Salesforce security model. So which is also the principle of least privilege. So just as I was talking about that user, that you want to make sure that you stay within the scope of the user, which is requesting the data access. So there are two kind of ways we see developers integrating the users for authorization within those connected apps, or for example for APIs, for example. So you can create an integration user. What integration user means is you can create a user, for example, API user, and then you use that user to make all the calls for your APIs or within your application. But there's a big security problem with integration user, which is that you are not providing or taking access for data based on per user. Instead, you created one user, which is like API user, who's making calls for all the other users. Some users might not need that much data access as compared to, for example, user A. Maybe he just needs to access to two or three fields, and maybe user B needs access to only one field. Now, an integration user, he or she can pull data for because the user permissions are set for that integration user, not per user level. So we say that you should always include the end user permissions, which is like you're authorizing application based on per user, which is also the OAuth flow of Salesforce that I'm going to show you as a demo, that how you can authorize per user basis on Salesforce platform. And once you map those users that are created. Good morning, good afternoon, and good evening to everyone joining us today. So today's webinar is about secure development on Salesforce platform. It's a part 3 webinar. I'm joined here with Swapnil Shinde and me, myself, Nitin Arya. I'm a product security analyst at Salesforce. I work on Apex security reviews. I mostly work on these reviews, then I talk back to partners and help them fix those issues. I've been helping understanding the security bugs within Salesforce, and I help the teams here remediate those security issues. I help them out during the security review process. I build some internal tools that we use within our security reviews in the Salesforce. I'm joined here with Swapnil Shinde.
Hello, everyone. This is Swapnil Shinde, and I work as a product security engineer here at Salesforce. Nowadays, I'm working with a team which is focusing on building security into our community cloud product. I also spend some time on reviewing the apps that are submitted on Apex, and I get a chance to talk with partners sometimes in order to resolve their issues. That's about me. Giving it back to Nitin.
Thank you, Swapnil. A quick legal statement, guys. Don't make any financial decisions based on this presentation itself. All the features that we're going to talk about today are already available on the Salesforce platform. So, agenda for today's talk. I'm going to be covering the external application integration within the Salesforce. And the second part is going to be done with by Swapnil, where he'll be talking about secret storage in Salesforce platform. um, More of the partners, whenever you want to integrate some external application or service within Salesforce, you can use the Salesforce platform in a more secure way. So we're going to talk about what are the ways you can integrate your external applications securely within Salesforce. Now, once you have these external applications talking to the Salesforce platform, you also want to be retrieving user data from the external services or pushing data from the Salesforce platform itself. So there are a couple of authentication or authorization method that we use within that integration. You can use the SOAP API, which will lead you to a user password-based login, or you can use the OAuth authentication flow within your applications. Easiest way is by using the OAuth. You receive an access token. Access token is a credential that Salesforce issues to you based on the scope user agreed to give access to. So once the authorized user is now okay with the access that he wants to have for that particular API, for example, the user has authorized you to that you can access his Chatter API, then you can make requests. You can pull data from Salesforce or post it back. You can also write down your custom Apex endpoints that I'm going to talk about in the next slide probably. So as we already talked about, there are two-way kind of APIs supported by Salesforce, SOAP, and REST. External services can authenticate with Salesforce via OAuth, and as we said, we can receive these access tokens. These access tokens are kind of like temporary passwords, so you use these access tokens to access the data within Salesforce. Now, as I was saying, they're kind of like temporary tokens. They provide access to the users. You want to make sure that they're treated with the same level of security as any other password or encryption key. The second part of this presentation, which is about secret storage, will cover all the key points on what guidelines you should be following in order to secure those credentials or these access tokens securely. You can utilize public facing APIs to share data with Salesforce instances. One other point that I want to talk about is the outbound messaging, and developers can expose custom Apex REST endpoints. What that means is you can use the already included REST API within Salesforce, but you can also create new custom Apex REST endpoints